Welcome Calculus BC. This is lesson 7.1 Improper Integrals. Let's begin. So how do you solve this problem? Well, that's the area under the curve between 1 and 8. So it'd be all this shaded area right here. So if I were to solve this integral, antiderivative 1 over x is ln of absolute value of x. You go from 1 to 8. So it's ln of 8 minus ln of 1. And ln of 1 is 0, so it's just ln of 8 minus 0, so it's just ln of 8. Cool. So that's how you'd solve that. Now watch this. I'm going to do something. What if it wasn't 8, it was infinity? Whoa. How do you solve this one? Well, it's area under the curve. Usually it's a definite area. We go from like 1 to a number, but now we're going from 1 to forever under the curve, and I can't draw a straight line. So how can you figure out the area under the curve if it goes to infinity, like it doesn't stop? That doesn't make sense. And yeah, it kind of does actually. So it's like when we're talking in infinities, as you go out forever, it's getting smaller and smaller. Sometimes those numbers actually converge to some number, like that infinity is approaching some number. So that's what we can do in these kind of problems. And these are what we call improper integrations. So integrals are improper if one or both the limits are infinite. So in the case of that last problem, we have an infinite limit, or maybe we even have two infinite limits in this case. And it's also improper if there's an infinite discontinuity. So not like a hole, like if you draw a line, you get a hole. That's not infinite. But like we're talking a vertical asymptote. So if there's an asymptote at or between limits. So in the case of number 3, you have an asymptote when x equals -1 because then you'd be dividing by 0 here. And in the case of 4, well, -2 and 2 is fine. But in between, when x equals -1, you actually have an asymptote in there. So you have to use improper integration techniques. And so this is one key thing to understand. Integral evaluates to a number when you integrate, or it diverges. This is a new thing this time. So diverges means the answer is infinity or negative infinity, but it includes infinity. So if you have infinity, that means your answer diverges. That means it doesn't converge to a number. It keeps like growing forever. So you can't get an answer. So how do you do these kind of problems? Well, technically when you're doing infinities right here, I'm going to show you technical definition. You're really just doing a limit. So I'm actually going to rewrite this one as the limit. So instead of saying 1 to infinity, I'm going to go like 1 to b of 1 over x dx. And it's a limit of this as b approaches infinity. So for being technically correct. Now, so how would I solve this? We'll just integrate this problem right here. So, integral of 1 over x is going to be ln of x from 1 to b. And so it's it's going to be ln of b minus ln of 1. So ln of 1 is just 0. So it's just ln of b and the limit as b approaches infinity, which will be ln of infinity. Now, what's ln of infinity? And when ln of infinity, ln keeps growing on forever. So that's actually the same thing as just infinity. So since my answer is infinity, we say it diverges. So if it was a multiple choice problem, diverges would be the answer, not infinity. Now I did this limit notation here. As you're working the problems, you can probably just plug in infinity. You don't need to do this, but technically we have to do this if we're showing work. All right? So it actually diverges. It actually keeps growing slightly forever. It doesn't converge to a number. We're going to try this something a little bit different. So this is 1 over x squared. Now this is like a partial graph of this. 1 over x squared kind of looks like this and this with an asymptote at 1 or at 0. So this area from 1 to infinity. Now does this diverge as well? Let's find out. I'm going to integrate 1 over x squared. So that's going to come out to -1 over x from 1 to infinity. I'm just going to plug it in this way. So it's -1 over infinity minus -1 over 1. Okay, minus -1 over 1 is just plus 1. And then this thing, -1 over infinity, remember 1 over infinity, actually just goes to 0. So we're at 0 plus 1, which is 1. So in this case, even though it looks very similar to the last one, this area actually approaches 1, so we can evaluate it to 1. All right, let's take this example, cosine, okay? Same principles here. Antiderivative cosine is going to be sine of x from 0 to infinity. So it'll be sine of infinity minus sine of 0. Now, sine of 0, our unit circle, we know this is 0, so minus 0, so that just goes away. sign of infinity. Infinity goes up and down between 1 and -1 forever. So this, it doesn't go to infinity or nothing. This thing by itself diverges, so the whole answer diverges. Like even though this is 0, if one part of the answer diverges, it diverges because it just oscillates between 0 and -1, so diverges. We could take a problem like this. I'm going to skip this. I don't keep doing these things, but you get the point. We'll do it in class. Okay, so sometimes we have a discontinuity in the middle, and so we need to split the problem. So take this example. -1 to 2 of, it's like 1 over x cubed. Well, at x equals 0, you have an asymptote if you're to graph this. So what we're going to do is we're going to split this up into two graphs. Go -1 to 0 of 1 over x cubed, and then we're going to go plus integral from 0 to 2 of 1 over x cubed. Now, really, it's not 0. We're actually looking, and if we were to graph this, I think the graph of this looks like, let's say it's an asymptote. I don't know what the asymptote looks like. Wait, I have a calculator. Let's actually look at that graph. I don't want to make it up. So 1 divided by x cubed. Be really good to see what this looks like. So pulling up TI-89, yeah, it's got these asymptote things going on here. So it kind of looks like that 1 over x equation. So it does this thing where we have an asymptote here at x equals 1. So what's actually going on here, it's not approaching 0 in this case. It's like 0 from the left-hand side. So I could even put a 0 minus right here and a 0 plus right here because this is 0 from the right-hand side. So we're talking limits again. So let's plug those numbers in. So antiderivative of 1 over x cubed. Okay, so if you don't remember how to do this, which I'm not quite drawing a blank right here. So you add 1, x to the -2, divided by -2. So it's going to be -1 over 2x squared from -1 to 0. And this one would be the same over here. So it'd be -1 over 2x squared from 0. We'll put that plus and the minus here to 2. So we got to think about this when we're approaching those asymptotes. Is it going up or down forever? Well, as you approach 0 from the left, even looking at our graph, it's actually going down forever. It's negative infinity. So when I plug that to the left, our graph is going to negative infinity. So I'm going to say it's -1. Am I doing that wrong? We're going to do that in class. And we're done.